Hi, in this video I'm going to show you how I do reverse engineering of this motorcycle fairing. This project was sent to me by a viewer from this channel, and he used his Creality Scan Raptor, the original version that was released last year for scanning this fairing, which is has a larger size, about 60 centimeters from this point to this point. Then the viewer has reversed this part by using automatic surfacing tool, the Design X, and he ran into the issue where the reverse part has a thinner wall thickness than the original scan. That's problem number one. The problem number two that he has is that he cannot create a proper joint. He divides the prints into 5 parts because the limitation of the printing volume, and he glue it together. The joint has a very large blob of glue from the outside. That is because the thickness of the fairing is only 3 millimeters. In some parts it's even thinner, so the contact surface for the adhesive is very thin. And the issue number 3 is that he couldn't modify the mounting point of the fairing. This fairing has like 17 mounting points, and the one that was scanned, some part is not 100% captured by the 3D scanner, as he cannot do the modification. Like the ribs here is very thin, less than 1.5 millimeter, so he cannot adjust any thickness. This one too, the ribs here is too thin. And the reason number 4 is that if you look at the original part, it has the standout edges which make the geometry of this fairing. But when he reverses it with the automatic surfacing tool, the Design X, those edges are gone. He lost control over the edges that has to be stand out, and it's all smooth out, and it doesn't look like the original part. So he asked me if I'm interested to show him the method that I use to create the curved surface manually using the regular CAD software. In this case, the Autodesk Inventor. If you do the reverse engineering properly in the CAD software, you have the full control of the edges and the curve of the fairing. You can make the edges stand out in a certain location, and you can also modify the mounting point of the fairing, make it more suitable for the FDM printing by removing the hollow part. This one is hollow, which is necessary for injection mold part, so that they can remove it from the mold easier. But if you are using the FDM printer, you can, for example, you can print this mounting in a solid cylinder, so it will be can be printed without the support and stronger. I can print this with a taper cylinder shape. I don't have to print the thin lips here, which is more difficult and is prone for breaking when you remove the support. The purpose of doing a 3D scan and reverse engineering is that you want to reproduce the part, and plastic part like this, you can easily reproduce it by using a 3D printer with a proper filament. The fairing that he scanned is from this motorcycle, Suzuki DL1000. He doesn't have photos of this motorcycles, so I took it from this YouTube video. It's a model from the year 2007, and this will be the left side of the fairing. This is I think it's a touring bike. It was made in 2007. The part replacement is quite difficult to find, and this is a very large injection mold part, 60 centimeters. I think it could be very expensive if you want to buy one of this. Okay, let's take a look at his scanning result, and I can say that he made a very good job at scanning this part. The interior of the fairing is almost complete scanned. There's some part here that has a deep gap. If he uses a smooth S1, he can capture all this. If he doesn't tell me that he used the original Raptor, I wouldn't believe it. I can see the seam line from merging. Let's take a look at the front. Okay, the front is also nice and clean. And this deep pocket is not entirely scanned, but it should be fine. At least I can see the bottom of the pocket, and I can see a faint seam line here. I think if he used the Raptor Pro, which has a larger FOV, he can scan both outside and inside using the global marker, and he wouldn't need to merge the scan together, and there wouldn't be any seam line. I think he put the limit to this Creality Scan Raptors. The price of the Raptor Pro is just a little bit more expensive, right? About $400 US more expensive. If you use this Raptor Pro to scan this fairing, you wouldn't have this seam line at all. Okay, because the viewer didn't send me the point cloud either, so I need to convert the mesh into the point cloud so I can reverse it by using the holodeck inventor. And the scan data is quite large, 11.2 million faces, and when I orbit, even within the cloud compare, it's very slow to orbit. I have a very fast PC, so I need to convert this mesh into the point cloud. I think I only need about 5 million points for this part. That would be enough for me to see all the detail. So what I have to do is just click on the mesh, click on edit mesh and sample point, and just type in the number of the point that I need, 5 million, and click on OK. And then I will have a point cloud that is much faster to orbit. So when you work with reverse engineering, you need to orbit all the time to check the tracing of the line. So if you orbit slower, so it will take a longer time for you to reverse. Let's talk a little bit about 3D printing. Because this part is too large for my printer, I have a K2 Plus, so my printing volume is 35 centimeters. And from this point to this point is 62 centimeters, so I need to divide it. So I will do this. I will cut a joint here. That's my first joint. That will be my second joint. So from this point to this point is over 35 centimeters, so I need another joint. So I think I'm going to cut the joints here. The mounting point cannot be in between the joints, so 4 parts in total. So I will reverse in this order, 1, 2, 3, and 4. Okay, here is in the Autodesk Inventor. I start by cropping the point cloud into a thin section to create a first sketch. Usually the thickness of the point cloud I use is about 1 millimeter. Click on the check mark. Okay, and then I use the cloud point to snap onto the point cloud. This is a cloud point. I need three points to create a plane, and then I create a plane. Okay, this is the plane I created. So it's quite important that your scan data need to have a thin layer of the point cloud. This comes from the accuracy of your 3D scanner. If you do this with the Otter, this line of the point cloud will be thicker, about 0.15 millimeter, but for the Raptors and the Smooth S1, it could be very thin, about less than 20 microns. This is the first sketch that I made, and I set the offset for the wall thickness to 3 millimeters. So you have full control of the wall thickness of the shell. Okay, next I do the same thing and create a second cross section, and this is the rails. I use the spline to create the rails. Click on 2 points here, and then I can add the vertex. If I add one vertex, it's going to be an arc, so I can move it, and then I need to move the vertex to match the surface from the point cloud. If you have a clean scan, you can easily match. It has some more space here. I need to lift it up a little bit more. You can move it by using a gizmo or by using the mouse, just drag and orbit it. So now you can match the curve of the spline to the curve of the point cloud. So if you add more rails, so this section, I have to say that I was in a hurry, so I didn't put as many rails. So the result from this model is not 100% because I don't have the time to do this. When the viewer asked me to reverse this motorcycle fairing, he didn't tell me that it would be this big. I thought it was a small part. The difference between the reversing with the point cloud and the mesh is that with the point cloud you can't see the wall. With the mesh you can't see this wall. When you turn it correctly, see here, you can see the wall line quite clear, and the scan from the Raptor is very good to display this wall line. If you can see it, you can trace it. The wall line is quite clear, so I can create a circle here. This wall line is quite clear, so I can trace the profiles and extrude it or loft it, sweep it quite easy, because when you model in CAD, you need to start with the 2D sketch and use 3D command, extrude, sweep, and loft to create a 3D models. But if you do this with the mesh, you won't be able to see any of this. And you can see that I orbit this point cloud quickly, because you're going to do 1,000 of orbits for modeling this part. So if you can orbit, zoom, and pan quickly, you can finish your part faster. So mesh has no advantage in the reverse engineering. So I'm going to show you all the steps I took in a faster way, because after this I will show you the printing process as well. Okay, here's a finished model, and you can see the standout edges. You can spend more time adding more 3D lines for the rails and adjust the curve, but for this demonstration I have something else to do, so I will send this out for printing so that you can see what it's like when it is printed. Okay, here's part number 1 and number 2. For this demonstration, I will use PLA for printing. This first 2 parts will take about 8 hours for printing. Okay, here's part number 3 and number 4. So I use almost the printing volume of my printer, 35 centimeters. Okay, I've already finished the first 2 parts. Okay, I need to continue with part number 3 and 4. 9 hours, 32 minutes. Let's try to remove the support. Okay, our support removed and nothing breaks. Okay, I will use this adhesive. This one has the acetone content, so it sticks very well with the ABS and the PLA. And if I print with the polycarbonates, PET and the nylon, I will use the epoxy. Okay, this should be enough for holding it until it's cured. And when you have enough contact surface for the adhesive, it will be a strong bonding, won't be breaking at the adhesive joint. It will break at the layer line instead. So if you choose high bonding filament like polycarbonate, this fairing part will be very strong. But you need to choose the right adhesive and provide enough contact area for the adhesive to work. So it's not going to break easily. This is only 3 millimeters, the same as the original part. It's a bit lighter because I print hollow. So I think it's possible that you will reproduce part this fairing this size using the desktop 3D printer. You can apply the filler and sand it and then apply the top coat. There's some part that I didn't do perfect match with the 3D rails, so you can't go back to the next inventor and adjust the rails, add more rails or add more cross section. So if you do this manually, so you have a lot of room for adding the thickness and the shape that you need. So it's the same approach. For example, the car bumper, you may need a larger printer. I have seen the printer, a resin printer that used for printing the car bumper. It has a 2.5 meters build plate, so you can print a bumper in one pass without any joint like this. When you reverse fairing or plastic trim like this, you should also scan the mounting point so that you can decide if you want to do modification, so that you will know how much space that you have. Thanks you guys for watching. See you in the next video.